In this video, I'm going to go over a shortcut method for partial fraction decomposition. So the last video I did on partial fractions, I started with this fraction. I broke it up by, well, I factored the denominator first and then broke it up into simpler fractions. What we did in the last video, we basically combined this side using the normal algebraic method of common denominators, and then equated coefficients across the numerator. And we ended up with a system of equations that we had to solve. So that is quite a bit of work. So there is a shortcut method. And the way that works is we start with one denominator, one of the simpler denominators, and we multiply the whole equation by that. So that's how we start. So let's start with x plus 4. If we multiply this whole equation by x plus 4, we'll end up with this. So just multiply everything by x plus 4. So I'm not changing the value of this equation. If I multiply something on this side, to negate that change, I have to multiply the same thing on the other side. So again, not changing it, just changing the way it looks. So one thing we notice is on this side, we have an x plus 4 term in the numerator and an x plus 4 in the denominator. So those will cancel. Over here, we have the same x plus 4 in the numerator, x plus 4 in the denominator. Those will cancel. So now the equation will look like this. Okay. So one thing to note, by going from this equation to this equation, we did lose one piece of information. So if you notice here, we have two discontinuities. We have one at x equals -4 and one at x equals +1. So those are two constraints on the value of x. If we plug in those values here, we would get a 5 divided by 0. Any divide by 0 is undefined, so we cannot have those. We cannot have x equals -4 and we cannot have x equals +1. Here in our new equation, we only have one term in our denominators, and that's x equals -1. So we lost this x plus 4 term from the denominator. We basically lost a discontinuity. We now no longer have a constraint on x at -4. If we plug in x equals -4, we won't get any divide by zeros. So let's do that. Let's plug in x equals -4 into this equation. So when we do that, and I'll write it over here, we'll get 5 divided by -4 minus 1. -4 minus 1 is -5, so we'll get 5 over -5 equals a. Plus, and notice here, when we plug in -4, we get -4 plus 4, that's 0. Anything multiplied by 0 is 0. So this whole thing will evaluate to 0. So we'll get 5 divided by -5 equals a plus 0, or just a. And 5 over -5 is -1. So right off the bat, just like that, we solved for a. So that was simple enough considering how much work we had to do in our algebraic method. So we solved for a, now we have to solve for b. So we solved for b in a very similar fashion, and I'll make it small. we found a equals -1. So to solve for b, we again start here. And now instead of multiplying everything by x plus 4, we multiply everything by x minus 1. So we should get this. And again, we see terms cancel here, x minus 1 in the numerator and x minus 1 in the denominator. And here again in the numerator and in the denominator. Okay, so rewriting, we find this. Okay, and now notice again that we lost another discontinuity. So we lost this x minus 1 term in our denominators. So we lost the constraint on x at x equals positive 1. We no longer have to exclude that, so now we can include that into our analysis and we can plug it in at x equals positive 1. So at x equals positive 1, we'll have 5 over 1 plus 4. That would be 5 over 5. And here, when we plug in 1, we'll have 1 minus 1, that's 0. This whole term will go to 0, turn into a 0, and then we'll have a plus. Or in other words, 5 over 5 is 1, and 0 plus b is just b. So b equals 1. And just like that, we're done. So not as much work